Can you believe it? The groundbreaking theory that reshaped humanity's understanding of the universe was rejected by the Nobel Prize. Today we uncover science's most controversial snub. To solve this mystery, we first grasp how revolutionary relativity was. 1905 was Einstein's Annus Mirabilis when the 26-year-old proposed special relativity, appending centuries of Newtonian physics. He put forward two counterintuitive pillars. First, the laws of physics are the same for all observers moving at constant speeds. Second, the speed of light is absolute to 199,792,458 meters per second, no matter how the source or observer moves. This was no minor tweak, but a total overhaul. Length contracts at high speeds, time slows down, and mass converts to energy via the famous mass-energy equivalence. Today's nuclear power plants, smartphone GPS, and even hospital radiation therapy all rely on this theory. But controversy erupted immediately. The scientific establishment, trapped in Newtonian thinking, couldn't accept that space and time weren't absolute. Albert Michelson, America's first Nobel laureate in physics, dismissed relativity as untenable until his death. In 1915, Einstein expanded to general relativity with an even bolder claim: gravity is not a force but the curvature of spacetime by massive objects. This solved a long-standing astronomical mystery, the anomalous precession of Mercury's orbit that Newtonian physics could never explain. The turning point should have been 1919. British astronomer Arthur Eddington led to expeditions to Africa and Brazil to observe a total solar eclipse. Einstein predicted starlight near the Sun would bend by 1.75 arcseconds, twice the value Newton's theory suggested. The results stunned the world. The stars' positions shifted exactly as Einstein predicted. London's The Times ran the headline, "Science's Revolution, New Theory of the Universe, Newton's Ideas Overthrown," and the Royal Society president called it the greatest achievement since Newton. Einstein became a global celebrity overnight. Surely relativity would win the Nobel now, but the story took a shocking twist. A group of conservative physicists launched a vicious attack. Among them was Nobel laureate Philip Leonard, who maliciously dismissed relativity as unreasonable fantasy and allied with another Nobel winner, Johannes Stark, to boycott Einstein's work. The Nobel Committee, bound by tradition and fearing controversy, caved. Their rule was clear: the Nobel Prize rewards proven achievements, not theoretical breakthroughs. Even with Eddington's data, some committee members remained unconvinced. They even commissioned an ophthalmologist to evaluate relativity. Unsurprisingly, his report called the theory lacking sufficient experimental proof. 1921 came and went, and the Nobel Prize in Physics was left vacant, an unprecedented snub for the world's most talked-about scientist. Public outcry grew, newspapers demanded answers, and the committee faced a dilemma. Ignoring global calls to honor Einstein would spark outrage, but awarding a controversial theory violated their conservative principles. Their solution, a historic compromise. In 1922, the committee announced they would retroactively award the 1921 Physics Prize to Einstein, not for relativity, but for discovering the photoelectric effect. This achievement had solid experimental proof that conservatives couldn't dispute, but everyone knew it was a consolation prize. Relativity was the real deserving winner. Interestingly, Einstein was traveling in Japan when he received the award telegram and remained calm. Later, he gave his Nobel lecture without mentioning the photoelectric effect at all, focusing entirely on relativity. It was his silent protest and commitment to truth. This story still matters today because it reveals a truth: the most revolutionary scientific ideas often outpace their era. The committee's hesitation wasn't malice but caution. They were used to rewarding incremental, verifiable progress, not rule-breaking innovators. For example, gravitational waves, predicted by relativity, weren't directly detected until 2015, 100 years after the theory was proposed. Today, relativity is everywhere. Your phone's GPS corrects for relativistic time dilation every day. Without it, navigation would be off by more than 10 kilometers. Astronomers observe distant galaxies using relativistic gravitational lensing, and our understanding of black holes and the Big Bang is entirely based on Einstein's theory. The irony is that relativity never needed a Nobel Prize to prove its worth. It's the foundation of cosmology, particle physics, and astrophysics, shaping the course of modern science. This Nobel snub didn't diminish relativity. It highlighted that true scientific greatness isn't defined by awards, but by the change it brings to the world. Next time you hear a new theory facing skepticism, think of Einstein's story. Progress is never smooth, and greatness is often met with misunderstanding. Do you think relativity deserved the Nobel Prize? Let us know in the comments, and don't forget to subscribe for more science stories that changed the world.